This is 7-level multi-level inverter. It is cascaded edge bridge multi-level inverter with SVPWM pulse generation. Okay, this is a single bridge. It consists of 4 switches and a single source. Similarly, 7 bridges are there. So totally it is 15-level multi-level inverter. Positive 7 level, negative 7 level, and it will be 15-level multi-level inverter. And here the pulses are generated according to the switching sequence of that multi-level inverter, and that will be combined with the SVPWM generator here. The SVPWM pulse generation. Here the pulse is generated according to the SVPWM pulse generation, and from that pulses are taken. Here it is for 6 pulses, that is 3-phase inverter. In that, first 2 is for the first phase, that is for single phase. First 2 pulses will be, first one will be positive cycle, second one will be negative cycle. So here second one will be negative cycle. If the sine wave is, that is the reference wave, is greater than 0, then it will be for positive cycle. If it is not greater than 0, then it will be negative cycle. For that, the pulses should be provided. That will be combined with the pulses generated from the according to the switching pattern, that is switching table. So the SVPWM and the 15-level multi-level inverter pulses are combined, and from that the output pulses will be provided to the switches S1, S2, that will be provided here. For will be combined with this. For positive cycle, this one, and for negative cycle, this one, second pulse. All will be combined and provided to the pulse generation, and it will be connected with this LCL filter, and that LCL filter output will be connected to the load. Here the load resistance I will provide as 10 ohms. Simulation will start to run. Here the power will be calculated from each bridge. Totally 7 bridges are there. So the power is calculated from the 7 bridges and added here, and that will be provided as the input power. Okay, this will be the input power. And that will be that is provided for efficiency calculation. Here this is the output power. RMS voltage and RMS current is multiplied, and from that output power is calculated. So output power by input power, we will get the efficiency. So in this scope, we can check the output power and input power. First one is output power. This is around 4150 watt. Input power is around 5710. So the efficiency is around 72%. and this is the voltage waveform. Current waveform. And here power factor is calculated. That is the angle of the voltage and the angle of the current is calculated using the PLL. And from that, the difference is calculated and provided to cos function. Here it is 1. The power factor is 1. And here in FFT analysis, SVPWM 1.21% THD it is coming. Similarly, we will increase the resistance. Okay. And this the voltage is around 204.6, current is around 10.19, and output power, input power, efficiency, those things we can see it here. Output power is around 2050, 2085 watts. Input power is around 2930, 920 watts. Efficiency is around 71 percentage. Power factor same 1. Here the THD is around 1.17 percentage. And then we change it to 50 ohms. For RL load, select this RL option. For 50 ohms, 50 micro Henry. I have provided micro because in the tabulation that you provided, power factor is 1 it is there. If we provide milli and all, the power factor will be deviated, it will reduce. Because the inductive load is high means, then the power factor will reduce. So I have provided micro here because it is not mentioned in that, it is provided as 50, 100 like that. Inductor value. So I have taken as micro here. Here the voltage is around 206.3, current is around 4.116, and this is the power factor. If you see means For this it is reducing, but still it is 0.999 like that it is there. So it is 1 only. So if you see means for inductive load, power factor will reduce, but here it is around 0.99 like that only it is coming. So we can term it as 1 unity power factor. This it will be similar to the R load only. Here the output is around 850 watts. Input power is around 1310 watts. Efficiency is around 65 percentage. And THT power guide tools FFT analysis SVPWM 1.04 percentage. So like this we have to vary the resistance and inductance values and check the results. One by one we have to check the results.